This video focuses on conservator liquid insulated transformers. You'll see these a lot at power generation facilities and in substations and also at large industrial plants. So let's start with the basics. How clean is the transformer? How rusty is the transformer? Are there signs of corrosion? Are there signs of oil leaks? We can actually see that this transformer is very clean and there are no signs of leaves on top of the transformer casing, no signs of sand accumulating around the transformer. We have a temperature gauge here. The black needle indicates the current temperature. The red needle is a follower needle, and that indicates the maximum temperature that was achieved since the needle was last reset. As we're removing more and more moisture from the air, the drying agent is actually going to change color. It does this because this helps us see exactly when the drying agent is saturated and when it can no longer absorb any more moisture. If we have 25% of the drying agent column which is saturated and 75% not, then we'll be able to see this because the lower 25% of the column will be a different color to the upper 75%. The bushings are a common failure mode for electrical transformers. I believe they're in the top 3 failure modes for transformers. So pay attention to the bushings, look at the condition, look for any signs of cracking on the bushing, any signs of dust accumulation, and any signs of scorch marks or black dark areas where the bushing might have been heated up considerably. The Buchholz relay is there to protect the transformer should it have a minor electrical fault internally, a major electrical fault internally, and also if the insulating liquid level should become quite low. So it's a very important device, but when we're walking around we want to check things like, is the arrow pointing in the right direction? Usually there'll be an indication like we're seeing here that should point towards the conservator tank.